Hi, I'm Matt, and today we're going to talk about auto racing. See, there's a lot of different types of auto racing, but a pretty familiar one would be NASCAR. NASCAR is an abbreviation of National Association for Stock Car Auto Racing. This was founded in 1948 by Bill France Sr. This actually involves science, and I'm going to tell you why. A lot of different types of forces are involved in stock car racing. One of them is drag. Some of you might be asking, what's drag and how does it relate to a stock car? Drag is a force that opposes an object's motion while it's traveling through the air. In other words, when a stock car is driving, air resistance tries to hold it back. More drag on a car can occur if the vehicle has more bulk or if it's lacking an aerodynamic feel or look. Drag can also affect the driver and the car. Another force is thrust. This force propels the car forward. In a car engine, the pistons spin. That causes the camshaft to turn. As you can see in this picture, here is the camshaft. Then when the transmission is put on, the camshaft spins the transmission. That is the transmission. The engine makes the car move. A force that would be necessary in this case would be gravity. Gravity helps objects stay grounded to the earth. Gravity allows a car to drive on the ground functionally without floating. Without gravity, the car wouldn't be able to stay on the ground and be unable to function. And this affects the driver too. Without gravity, he would be floating everywhere just as well as the car. Then there's G-forces. A G-force is basically acceleration acting like weight when an object is traveling at a high speed. Driving slowly in a vehicle can cause a light G-force. A vehicle with a quicker acceleration has a greater amount of G-force. The person driving will be compressed in their chair when it comes to high G-forces. For safety, the driver wears a helmet and fireproof clothing while driving at high speeds. They've also added safety nets for the driver's sake. They added flaps on top of the car so if they flip over, the car won't completely go out of control. Like this one.
Rusty Wallace 20 feet in the air, spinning, crashing.
They even replaced the concrete walls with steel and foam. In 2007, Nascar designed a car that turned out to be bigger and safer than any other. Newton's law of motion also takes place in this too. Newton first stated that all objects that repeat a motion will keep moving unless a force stops that object from repeating the motion. Like when this car crashes into the sidewall, the repeating motion changes. So in this case, friction is a force that stops the car from repeating its motion. He also said that force can travel in the same direction as acceleration. This makes a lot of sense, and I will explain why. When an object's force travels, it moves with a certain amount of acceleration. And acceleration is how quick an object can change its speed. So it kind of has to move in the same direction as force. Newton finally stated that for every action, there's an opposite equal reaction. If a car crashes and rolls over on the track, it will pretty much be bouncing up and down like this one. You see how it hits the ground and then springs right back up? That's because the downforce of a car has an equal opposite reaction. Another term is momentum, which is basically the force or speed of movement. Momentum can be caused by the movement of an object. If a person is driving a car that holds in the clutch, the car will keep moving because of momentum. You can't forget speed, but what is speed exactly? Well, it's a repeat of movement or action over time. Speed's formula is distance over time. Stock cars can control their speed by using the gas, clutch, or brake. Another term is velocity. It's really similar to speed, it just depends on where the object is moving. You can determine the velocity of a car as it moves. Cars can change their velocities at any point of time. So the main difference of velocity from speed is it includes speed, but also determines the direction that the vehicle or object is traveling in. Potential energy takes place in this too. This is the stored energy that an object has. When you start a vehicle, it contains gravitational potential energy before it moves. Then when it moves, the gravitational potential energy decreases because it converts into motion, or kinetic energy. So there's less gravitational potential energy when kinetic energy, or motion, takes place. So this must mean that kinetic energy can also be converted into potential energy. And it has a formula. It's Ke equals half times mass times velocity squared. Well, that's all the terms for today. And remember, what was it? Oh yeah, this is science.